What are you going to do first? Divide by 2. Good. Add 1. Great. Well, at this point,
Not that. 2 exponent to the thing.
I earlier was saying, why did we use ln? I was using it was a base E exponential, so I used the base E logarithm. So if you take me literal, you are going to do a base 3 logarithm right now. We're taking a base 3 logarithm. In the end, we don't have a button for base 3, right? So I would still pick either the ln or the log. So let's still ln it. So let's ln both sides. When the exponent comes, this time though, I don't get rid of it. It's x times the ln of 3. Right? It didn't undo it. It wasn't the inverse property. So the last step is divide by the ln of 3 on both sides. So you have the ln of 6 divided by the ln of 3. ln of 6, I'll go back, divided by the ln of 3. See, I didn't close it. ln of 6, I hit it, I think, but it didn't record it. The only way you'll be able to tell is to go back and listen to the clicks on the board in the video. Okay, so ln of 6, close it, divided by the ln of 3. 1.6 1.6039. Oh, jeepers. 6309. Exact value and the approximation. So quickly though, right here, when we had the 3 to the x equals 6, if you are starting to really process logarithms and exponentials, we talked about what's the base. You know, it's base 3. Do we have a base 3 in the calculator? No, we don't. When we did the base change yesterday, where did the base go? On the bottom. The other number goes on top. You can jump right from this exponential into the base change formula. Right? And that's why I said if you want to do a log base 3 at this step, you could do log base 3 on both sides. So I have, it does actually do the inverse property, it gets rid of it. So now, what do? Base goes on the bottom, the other number goes on top. You go right into the base change formula. So if you take me literal, always use the logarithms, so the exponential and logarithm are the same base. This is not anything that I would expect any of you to know, but it's just something that you might try. The issue we're going to have here is that we have more than one base that has an exponent containing the variable we're solving for, right? So you have e to the 2x and you have e or negative e to the x. So it's in 2 locations. There's really nothing you can do with this problem, but what does it look like? It kind of looks like what? Kind of looks like a quadratic, right? So what we're going to do is just say let w equal e to the x. So sometimes in math we have to do a substitution to kind of work our way around things. So then this would be w squared minus w minus 20. Because when you look at the first one, if I have e to the x being squared, they multiply, so that's what it is. So how does that quadratic factor? -5, +4. So when you set each one of those equal to 0, I get 5 and -4. Is that my answer? No, that's my substitution. So I just solved using my substitution. Now we have to take this and go back to there. So I have e to the x is equal to 5, and I have e to the x is equal to -4. What are you going to do? What? ln it. What happens when you ln and e? They're inverse operations, right? So I'm left with x. ln of 5. What happens over here? Remember that an exponential function, if you draw it in the air, follows the x-axis, hits 0 when it goes up. So it's never touching 0, let alone going below to -4. So my only answer is ln of 5. If you want to type it into your calculator to get the approximation, go ahead.